Okay, so the next couple of problems are just practicing the skills we learned in this lesson and some previous lessons to finish up our lesson for today. So when I have negative 4 plus or minus root 48 over 2 and I'm trying to reduce it, I need to reduce root 48. So I'm going to kind of come down here and work on just root 48 for the moment, and then I'll go back and deal with a fraction, okay? So let's see, 48, that's like 4 times 12, just 2 and 2 and 4 and 3. 2, 2. I like to bring everything down so they're all on the same level. I'm looking for groups of 2. So the 2 and the 2 come out and the 3 stays home, which gets me 4 root 3. Now, that was only this part of the whole problem, right? So let's go back and put it into the fraction. Negative 4 plus or minus, and then we have the root 48, which I know reduces to 4 root 3 because I just worked on it, over 2. Okay, do I have an I? Well, no, so I don't have to split it up. But I do have to reduce. So here 4, 4, and 2. Can 4, 4, and 2 all be reduced by some value? Yeah, they can, and I can divide everyone by 2. So if I divide by 2, I get negative 2. Divide the 4 by 2, I get 2, and divide the 2 by 2, I get 1. Notice I left the root 3 alone because it's not a coefficient, it's not outside the radical. So this reduces to 2 plus or minus 2 root 3 over 1. But no one writes over 1, so we can just simply write negative 2 plus or minus 2 root 3. And that's how you're going to simplify this. Okay? The next problem has root 100. So let's focus on root 100 here for just a moment. What is the square root of 100? Well, that's plain 10. And if you forgot that, like if it's one of those things that you forgot, you could just do 10 times 10 and then still take it out, and then it's just 10, okay? So what stays the same? So we have negative 6 plus or minus the square root of 100, which we now know is plain 10. Okay, do I have a radical? No. Do I have an I? No. Well, because I don't have a radical or an I, this means I can actually evaluate the top. I happen to know what negative 6 plus 10 is, and I happen to know what negative 6 minus 10 is. So because this turned out to be integer, I need to actually finish the problem. Negative 6 plus 10 is 4, and 4 over 4 is 1. Negative 6 minus 10 is negative 16. Negative 16 over 4 is 4. So the solution, it reduces to 1 or negative 4. So we just put a comma between them so you have the two answers. Okay, let's look at the next one. Again, I'm just focusing on the root for a moment. Negative 50, the square root of negative 50. Well, first of all, we have the square root of negative 1. So I know my problem's going to have an I in it somewhere. But root 50 breaks down, so I'm going to have to break that down here. So that's 5, 5, and 2. The 5 goes out of the house where the root 2 stays home. Pairs go out, singles stay home. And then the I is going to be there as well. So looking back at my original fraction, we have 3 plus or minus 5i squared roots of 2 over 2 here. So now let's look at all the coefficients. The coefficients are 3, 5, and 2. Can 3, 5, and 2 be reduced? Or they have a common factor? No. But because I have an I, that means I need to separate the real part and the imaginary part. So the real part is the 3, plus, and the imaginary part is the 5i root 2, and each of those has to be divided by 2. Okay. Now 3 halves can't reduce and 5 halves can't reduce, and so that's my final answer. I have to separate them into 2 fractions because one has to be real, one has to be imaginary, so that it's in the form a plus bi. All right, let's take a look at the next one. Root 4. Root 4 is plain 2. So that means the 12 plus or minus root 4 turns into plain 2 over 18. Because I don't have a radical or an I actually have to evaluate the rest of this. I happen to know what 12 plus 2 is and 12 minus 2 is. So I'm going to break this up into the positive part and the negative part because there is no radical. So that gives me 14/18, or 7/9, and then 10/18, which is positive 5/9. So the two answers I get are 7/9 and 5/9. That's because the radical went away entirely. Okay. All right. How about when it's a square root of a -9? Square root of -9 is the square root of -1 times the square root of 9. So because there's a negative, that tells me I'm going to have an I. The square root of 9 is 3. So in my fraction, I have 12 plus or minus the square root of -9, which turns into 3i over 3. Because this has an I need to break this up into the real part, which is, actually I can reduce first, can't I? Let's do that first. 12, 3, and 3. 12, 3, and 3. What can 12, 3, and 3 all be divided by? Well, they all can be divided by 3. So if I divide 12 by 3, I get 4. Divide 3 by 3, you get 1. Divide 3 by 3, you'll get 1. So that gets you 4 plus or minus 1i over 1. But no one writes over 1. So it's just 4 plus or minus 1i. And in fact, you probably could put 4 plus or minus I. There's no need to put 1. But you can. It's not going to hurt anything. Okay. Another way you could have possibly done that is you could have just broken them up, 12 over 3 plus or minus 3i over 3, and you're still going to get 4 plus or minus 1i. Either way, it both works. Alright, last problem. I have root 27, which can be broken up into 3 times 9 and 3 and 3 and 3. So that's 3 square roots of 3. So on this problem, we have the 3 square roots of 3. We still have a radical. There's no I, so I don't need to split it up into real and imaginary parts because there's no I. Can 12, 3, and 17 all be divided by the same number? Well, I don't think so. 17 doesn't look real helpful there. So that's as far as I need to go on that problem. Okay, this concludes our lesson on the introduction of complex numbers and simplifying expressions with radicals.